Okay, let's take a look at some practice problems from 3.1. There's only a few types. The idea behind this first section is just that you are familiar with the x and y axis. So we have the horizontal number line being the x-axis, the vertical number line being the y-axis. And we saw how the very center is called the origin. And as we travel out to the right, this is the center of the x-axis, so this is 0, and as we go to the right, that's positive 4. So we go to the left, negative 1, negative 2, negative 3, negative 4. As we travel up the y-axis, that's positive. As we travel down the y-axis, this would be our negative direction. Right, so the two axes do split up the graph into 4 separate squares. We call each of those squares a quadrant. And we label the quadrant starting in the upper right. This is where everything is positive. The x-axis is positive, the y-axis is positive. Any point in this quadrant has all positive coordinates. And we call this quadrant 1. And we go counterclockwise, quadrant 2, quadrant 3, quadrant 4. All right, but for our purposes here, we're going to want to be able to do 3 separate things. Let's make a quick graph. There's our x-axis and our y-axis. First thing you'll want to be able to do is plot. Plot some coordinates. Okay, so if we wanted to plot 3, 1, okay, remember that every coordinate is an x and a y, or every point, sorry, has an x coordinate and a y coordinate. Okay, so if we're going to plot this point, we need to travel on the x-axis, so the horizontal axis, to where x is positive 3. We need to travel on the y-axis to where the y is positive 1, and those two locations, those 2 points are going to meet at one single point, 3, 1. I'll just pick some other random points. We want to be able to plot negative 2, negative 5. Right, again, that's going to be our x. So on the x-axis, I have to travel negative 2. And I probably shouldn't have picked negative 5. Let's pick negative 3 because my graph isn't even big enough for that. So let's go x is negative 2. And on the y-axis, I have to go to negative 3. And these two are going to cross at negative 2, negative 3, this point in space. It has the coordinates negative 2, negative 3. And one more quick example, 0. We'll do 2 examples. 0, why do I keep picking 5? 0, 1. Right, so that's 0 on the x-axis, so that means I'm not traveling right or left. So I'm going to stay right here, but I will have to go up 1 on the y-axis, so this point will be on the y-axis. Right, these are all random points. They're not going to connect and make a line or anything like that. And one last example, let's say negative 3, 0. Okay, so this is different from this point because now I have an x value, so on the x-axis I have to travel negative 1, negative 2, negative 3. Okay, but I'm going 0 in the y direction, so I'm going to be stationed right here. This point is negative 3, 0. And I believe I mentioned something about these 2 types of points in the last video, but this point is the y-intercept. It's on the y-axis. It's the y-intercept, and it'll always have an x-coordinate of 0 because it's only going to be traveling up or down. This point over here is appropriately titled the x-intercept. All right, it's always going to fall, or any point on the x-axis would be called an x-intercept. And notice it's always going to have a y value of 0. because we're not traveling up or down at all, we're just traveling along the x-axis. All right, so we want to be able to have that skill, taking any coordinates, any set of coordinates, and plotting them on a graph. And you want to be able to do that in reverse as well. So another quick graph over here. So we have, again, our x-axis and our y-axis. And if I plotted some points on here, point A, point B, point C, and point D. All right, we want to be able to find the coordinates of those points. It's a good skill to have. It's essentially doing this backwards. Right, so point A up here. All right, we want to find the coordinates of that point. That means we need an x and a y coordinate. All right, we're always going to write the x first, y second. So, all right, you just want to travel along the x-axis to see where A lies. And in regards to the x-axis, it's over at 1, 2. It looks like that's good. So on the x-axis, it's over to the right 2, so that's a positive 2. And on the y-axis, it's up 1, 2, 3. So that should be a positive 3. Point B, again, on the x-axis, 1, 2, 3. And that's where that's where B falls on the x-axis, and on the y-axis, it looks like it is down 1. Okay, so since I traveled down, that'd be a negative 1 on the y-axis. Point C. And on the x-axis, I have to go left 1, so this would be negative 1 on the x-axis. And then I travel up 1, it'd be positive 1 on the y-axis. And lastly, D. On the x-axis, I don't have to get to D, I don't have to travel anywhere, left or right. I'm just going straight down. So since I'm right in the center of the x-axis, since D falls right in the center, that'd be 0 on the x. And I have to travel 3 spots down, so that's negative 3 for y. All right, so we can take any ordered pairs and we can plot them on a graph. We can take a graph with a set of ordered pairs and we can find their coordinates. And lastly, which we saw in the previous video, is we want to be able to find solutions to a linear equation. Right? We talked about how ordered pairs are all considered solutions to a linear equation. So if we had something like 3x plus 4y equals 12. And if I said find the solution where let's see. All right, if I ask you to find the particular solution to this equation, right, where the x value is 0, so we're trying to fill in the blank and find the y value that would need to go with this x value to make a true statement up here. All right, so I tell you here that x is 0, you can substitute it in. All right, now you have a little equation to solve. This is going to be 0, 3 times 0, so that'll go away. We're just left with 4y equals 12. And you divide both sides by 4. And the y value that would go with this x value is 3. So there's our particular solution that I asked for. Right, you could keep asking for different solutions. I could say find the solution when, let's look at a different example, when y equals what do I want y to equal? I'd like y to equal negative 6. Okay. All right, if y equals negative 6, okay, we can go into our equation and substitute in negative 6 for y. Okay, I'll make some space right here so we can try it again. If we substitute negative 6 in for y, we would have 3x plus 4 times negative 6 equals 12. Multiply this, 3x, that'd be a negative 24 equals 12. Now we have a little bit harder of an equation to solve. 2 steps here. Right, but this should be natural by now. Plus 24 plus 24. 3x equals 36. And divide by 3 on both sides. And we end up with x equals 12. That's off the map. You can't see that, right? But you can see that we divided by 3. And our answer should be x equals 12. So, all right, this ordered pair should work if x is 12 and y is negative 6. All right, that would make a solution to this equation. All right, so there's the 3 types of problems we have in this section, and you should be good to go.